All right, guys, let's jump into section 10.2 here. All right, so this is the 10.2 PowerPoint. It is quite long. So I'm not necessarily going to go through every single word because you can read as well. And some of this I hope is a repeat from math in the past. But basically, this is all about displaying data and different ways of doing that. So we have numerical data, or categorical data. So categories would be like, do you like to eat hamburgers or pizza or hot dog for lunch? Numerical is like, how often does this thing occur? We have dot plots, we have stem and leaf plots, histograms and bar graphs and circle graphs. So definitions that are important here. Data analysis usually refers to more informal approach to statistics. So that is just kind of looking at the data and it's kind of informal. Statistics was once referred to numerical information about the state of political territories. It comes from the Latin word statisticus, meaning of the state. So statistics, there's a whole course on statistics that you may take later on in your college career, and this is just skimming over the surface. So we're going to basically look at the data. So let's kind of jump in. A pictograph is used to represent tallies of categories. So for example, we might see the month where most automobiles are sold. The month is the category, and a symbol or icon is used to represent. So pictograph has this word in it right here. What do you see? What word does that look like? It looks like picture, right? So you're using symbols or icons to represent an amount. And the biggest thing with a pictograph is make sure you look and see what the units are represented by. So each of these little stacks of newspapers represents 10 kilograms. So this is not just 1, 2, 3, 4. It's not 4 in July. It's 4 times the 10, which would give us 40 kilograms in July. So just be careful that you pay attention. This is the key for pictographs. That is pictographs. Let's look at the next one. We have an example of pictographs. So this is an example of how you would change this frequency count into a pictograph. So here's a table. Ames, it says 20. So that's how many kids are in her class. But then we could do that with a picture if we write it over here and we're like, okay, each of these little guys right here represents how many students? 5. So 5, 10, 15, 20 kids in Ames's class. You're able to just look at a pictograph and get a good representation just by a visual. We can clearly see who has the most people in her day. And you can kind of make a comparison. She has one of these more than the others. So that would be 5 more kids in her class than other people's classes. It's really important when drawing a pictograph that these symbols are the same size and then that they're lined up when you're drawing them if you were to have to make one yourself. Just because if I drew something with one man like this and then I had a huge man and then this one wasn't lined up down here, then it would be hard to just glance at the data and get the information. So it's just important that all of them are uniform in size. Dot plots are what you would imagine. It's dots, okay? But they are typically used when there's only one group of data with fewer than 50 categories. So suppose a 30 students in Abel's class received these test scores. Here's just a list of all these test scores. And then this is a dot plot. Basically, you make a scale on an axis. So in this case, we looked and we're like, okay, what's the lowest grade? If we go back and we see what's the lowest grade here, it looks like we have a 52. So I know that my scale needs to go to 50. And then the highest grade, of course, would be 100 or up to 100. And then we're putting an X each place the test person has that score. So we can see one person, and then you need to figure out if you're counted by ones or twos here. Here we're counted by ones, 51, 2, 3, 4, 5. So make sure you check the scale here to see if it's counted by ones or twos, or fives or tens or something else. But here we can see one person made a score of a 52. Here one person made a score of a 70. What score was the most frequent score? Well, we can see that's this right here because there's 4 students with this score, and that score is an 82. So if the question was, what was the most frequently scored score on the test, it would be 82. So that's just how to read a dot plot. Let's see, let's talking through that. Oh, an outlier, sorry. So an outlier is where there's something that's like outside of the data. So if we notice, all of these points are kind of clustered together. And so this guy is called an outlier because he's not close to the others. And this is called a cluster because we have this gap here, but then we have this group together, where then we have those IAs on the other end. So that's kind of explaining those terms here. Outlier is one what's outside of the data. A cluster is isolated groups of points. Gap, and then the word mode is the one that occurs most frequently. This is a stem and leaf plot of all of the data representation. I think this one might be the one that's the newest to you, or at least it was just a review for me. So stem and leaf plots are different, and it just takes a little practice reading them. So what you do here is make sure you read what it says on this side. It says when you have a 9 and then this bar here and then a 7, that represents the grade of a 97. So this represents we have a 52. We had no grades in the 60s. This represents a grade of a 70, a grade of a 72, another grade of a 72, a grade of a 73, 75, 76, 66, 77, 78. So you're seeing a number here for each of the 1 spots in the 70s. And then this would be the grade 80, and then the grade 81, and then the grade 81 again, and the grade 82, 82, 82, 82. So that's that mode again, because we have 1, 2, 3, 4 of them. 83, 384s, 85, 86, 88, and then this would be 397s and a 98. So that's how you read a stem and leaf plot. I would say that that is probably the trickiest one in this data. So advantages, they are easily created by hand. They do not become unnameable when the volume of data is large and no data values are lost. The disadvantage of stem and leaf plots, we lose information. We may know a data value exists, but we cannot tell which one it is. So how do you do this? You find the highs and the lows. You decide on the stems. You list the stems in a column from least to greatest. Use the piece of data to create. So let's see if we're going to make this here. So this is another example of a stem and leaf plot, but it's called a back to back. So this is comparing Abel's class test scores in her 5th period and 2nd period class. So this is tricky because you're basically reading this data front and back. So I'm reading this way to see her 5th period class. So she would have had a 52, and then a 62, and a 64, and a 71, and 72, and 77, etc. So reading this direction to read the grades for 5th period. So Mrs. Abel or Mr. Abel, their 5th period class, we have that data. I'm going to use red over here. This one we're going to read backwards. So 50 would be in grade in 2nd period, and 52. And this would be 61 and 63 and 65. So you can kind of line them up and then you can easily see, all right, which class scored better? Well, it looks like that her 5th period class had more scores in the 80s, whereas her 2nd period class had more scores in the 70s. So overall, which class period had the higher averages, that would have been the 5th period class. So you can kind of glance at the data and see information when it's organized this way. So here's an example of ordering this data into a stem and leaf plot. So these are the ages of the presidents at their death. So if you look at this, you can see the first several presidents written out to the age at their death. So if we're supposed to create a stem and leaf plot, let's see how that would look. So this says that they divided it into early presidents and to later presidents. And first you had to look, okay, what's the youngest that a president died? And you see here, John Kennedy was assassinated when he was 46. So 46 is the youngest. And then you scan the data for the highest. It looks like we have 90. Oh, 93 maybe. Let's see. So we come over here. Whoops. Let's get that. So 93 was the oldest. And so we go from the 40s to the 90s. And then they put the earlier presidents on the left side. and then the later presidents on the right side. So 49, 46, 57, 58, 57, 53, 56. So looking at this, which ones died? Which ones lived longer? It looks like there's a lot here that lived into the 70s, whereas a lot of these guys lived up here. So it looks like the earlier presidents actually lived longer than the later presidents. So histogram and bar graph. So this is basically a bar graph. So let's look at this. The death ages are shown on the horizontal axis and the numbers along the vertical axis. So this time we kind of grouped them by decade. So we got the 40s, the 50s, the 60s, the 70s, the 80s, the 90s, and you can see that most of them lived to be 60 to 70. So this is another way to represent the same data. A bar graph is typically used with spaces between the bars, and it's used to depict categorical data. So that's the difference between the two. The histogram is very similar to a bar graph. So this is representing people and their heights. That's just an example. This is a double bar graph where we see later presidents, early presidents, and again, we see that how the frequency will looks like it looks like 7 presidents lived in their 70s in the earlier, whereas only 3 lived in their 70s in the later group. So again, with any of the bar plots, lines, any of this data representation, the big takeaway is make sure you read the axis, make sure you read the labels, make sure you realize what are we counting by before you answer a question. So just be really careful with the scale, be really careful with just making sure you're reading what is being represented. So let's see if there's anything else. This is talking about a percentage of shoes. So dress shoes, flip-flops, Crocs, loafers, tennis shoes. This is another way to show a bar graph. It's kind of more like a pie graph, but instead of a pie representing a whole, it's one bar representing a whole. Let's see, business expenditures, and then this is showing materials and labor. So this is another way, it's called a stacked bar graph, where they're giving you kind of a percentage of cost. And so you can look at this and see, okay, how much am I spending on labor versus material? And then a pie chart is great. This is the consensus circle graph for the survival group and the death group and make comparisons. So then it says the measure of the angle for the first class passengers is 202 over 710, or 28.5% of the circle. So let's talk about that. So I would need to know the total. So of survival, what is the total? Because when we make a pie chart, we have to make sure that we're doing part over whole, because when you go to divide this, you need to know what percentage do I put here. The way to figure out this is you always do part over whole. That's how you figure out the percentage. So you're going to take this part and then put it over the whole. You're going to take this part and put it over the whole, and this part and put it over the whole. So you can figure out the percentages for the survival and then likewise for the death. So we see that here where they explain, okay, so the degrees, I'm sorry, percent, 28.5, 66.6, 25.1, and 29.9. Now, approximate degrees is what percentage of the circle do we have? Well, how many degrees does a circle have? You guys know? All the way around is 360 degrees. So if you take 28.5 and multiply times 360, the percentage is actually going to be 0.285 times 360, you will get 103. If I do 0.166 times times 360, I get 60. So you're going to multiply, or you could take this fraction, but it's part over whole, and it's the percentage. And to make the percentage a decimal, you're going to move the decimal 2 places over to the left and then multiply it by the total degrees in a circle. So when you go to graph it, you can kind of see it. But if we're just doing multiple choice here, it's not hard to kind of put them in order. That would make sense. So through you can see here, first class and crew are the ones that survived the most. And here in the survival, and then here in the death, the least amount of first class died. And I guess the crew was kind of the people that survived, it was higher, but it was also higher of people that died. So that's an interesting fact. But that is how to display data. Hopefully that was helpful. And as you work through the examples, it will become more clear. So practice, reach out if you have any questions or you need help.